Hey folks, happy Thursday. Happy Thursday. Hope you're doing well. This was a little rough. I guess. My apologies. This project 2. Lots of little things here. So we'll take a look and see. I'm going to go over my solution to it, and we can go from there. Okay? We'll take a look and see how it goes. So I don't want you to feel too down. Lots of people had lots of trouble with it. That's okay. It was a lot to it, right? From 0 to 100, yeah, definitely. So just a second ago, this happened. This is downstairs, my dishwasher. Someone put in dishwashing soap, not dishwasher soap. So I go downstairs and I see this. It's like, that doesn't seem right. So, okay. Apparently they're not the same thing. Who knew? So I hope you guys saw and had a chance to look at some of the tips I went over with the morning class. We kind of flushed out a little bit of what the structure might look like. Okay? So, we'll see. I don't want to go over too much of it, but I'll talk through it real quick as we finish building it out. So we talked about card. Implementing this comparable bit here, right? And then if we did a compare to, we're able to sort them using the collection sort or arrays.sort, depending if we're using an array list or not. So that's awesome. And actually, I was going to change this in. That's fine. That's fine. Get suit. We also needed an enum for face. So enum face, and then we'd have 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, and Ace. And remember with enums, the order is where they get their ordinals from. So the first one will probably be ordinal 0, 1, 2, 3, and on and on and on. So I can just compare the ordinals. So to compare, all I need to do is return my face dot... Oops, I need a face property, don't I? I have it face. There we go. Face dot get ordinal. Face dot ordinal. Nope. Ordinal. Come on. Ordinal. Right. Minus the other dot face dot ordinal. Ordinal. Yep. So if we're the same face value, right, we're going to be equivalent, equal to 0. It means that we're the same face. If mine is greater than theirs, I'm going to be a positive number, and positive means I'm greater. If mine is less than, it'll be a negative number. Okay, so we've got that. Then we also need a constructor then, and we need a get face as well. So I'm going to let the code, let NetBeans do the code for me here for my getter for face. I'm going to get face. Get face. Okay, awesome. So we got face there. Got our enum types. Just clean that up a little bit. And here's our constructor then. Let me actually put these enums up a little higher. Okay, and then we'll do our other constructor. So a card constructor here then that takes a face, and a suit. Okay. In real life word ban on the word method. Okay. I will try. I'll do my best, Crow. Let's see what I got. Right, so if you give me a face, I'm going to set my this face to the face and my this suit to the suit. Right? Just take those values. Got them. For the copy constructor, again, my this, or I can just say face, right, is card.getFace, or I can just use face, right, because I'm inside the code. I don't have to use those public methods. And suit is card.suit. Just copy them off of the other card. Yeah, that's right. I've got other words here, right? Other words I can use. Okay? So nothing super fancy here for card. Hopefully this wasn't too bad for you guys. And this compare to, right, using the ordinals we talked about. Not a problem here. Okay? Deck then, now, should have an array list of cards. Array list is much better than arrays because then we can actually remove from them and use random. So we're going to make a bunch of cards here so I can loop through my enum. So I can say for card.face in card.face.get values. They're dot values, right? Values. And I'm going to do another loop then. So I'm going to say for card.suit in card.suit values. So give me every value in suit here. I'm going to add a new card. So I'm going to take my card, I'm going to add a new card given the face and the suit. Face and suit. Cards. So I'm going to populate my deck here of 52 cards right here. You're banning both method and function. Okay. I got to come up with an interesting word for it then. That's all right, we'll give it a try. And I just want to make sure this is the right order. Right, we want a face and a suit. So like 2 of diamonds. Sure, that should work. And then I make a new random. Right, the constructor's job is to set values for our attributes. A couple of people had trouble, just because you declare it up here means you still need to initialize it, give it a value in the constructor. Yeah, you can use shuffle. There's a collections method to shuffle if you want, or just getting a random card out. Either way is perfectly fine. Really, it doesn't matter. It doesn't matter one way or the other. So to give you a random card, I'm going to get a random integer from 0 up to the size of cards, and then I'm going to remove that card and return it. This will just pick a random card from the deck. Either approach is fine, shuffling or not, doesn't matter. So some people might have shuffled. People found shuffle, which is great. I'm glad you found these things in the library. The Java library is awesome. You do collections.shuffle, given cards here, and it will shuffle it. Okay, either way is okay. I'm going to leave that commented out because I didn't bother with that. And then get random card, you could just get like the first card off or whatever. It would perform better if you got the last card off, but again, not too big of a deal. Don't worry too much about it. Okay, so that's our deck. So we can get a random card. Yeah, you just get a random card's easiest. And then the poker hand itself, right? We talked a little bit about this. It should have its own list of cards. You hand it a list of cards, and we go and copy them. Again, this is a little bit silly. The card class is immutable. We don't have set functions, so there's not a big reason we would want to do a copy, but this is just going to make sure that I have my own instance now using this copy constructor. So I'll take the card, hand it the card you gave me, make a copy of it, add it to my collection of cards. And then I use sort. We can sort if we have that compare to method. Okay, and then I did a enum for rank, right? High card, pair, two pair, three of a kind, straight, flush, full house, four of a kind, straight, flush. And then an enum for result, win, draw, lose. I think one or two people had asked about just using compare to and poker hand. That's probably a better way to go about it, but this, I think, is more straightforward for what we're doing, and that should be okay. And then we said, okay, let's figure out this call. So if one hand calls another, you give it the other hand, I'm going to see which one wins. So if my ordinal is greater than yours, I win. Right? If I'm a later one of these ordinals, I'm a better hand than you. If my ordinal is less than your ordinal, I lose. Okay? Otherwise, we have to figure out how to tiebreak. If our ordinals are the same, if we're both four of a kinds, well, how do I figure out which one's better? If we're both three of a kinds, how do I figure out which one's better? On and on and on. So we're going to go on down and figure that out. All right, but to get hand rank then, all of that magic happens in here. So, okay, well, how do I figure out what the rank is? So, well, I'm going to have a bunch of these helper methods here. So if I'm a straight flush, return straight flush. If I'm a four of a kind, return a four of a kind. If I'm a full house, return full of a house. If is, what was the next one here? I got to go in order here. Flush is flush. Return rank dot flush. Capital R rank dot flush. There we go. And I'll just give that a little format here. And then if is straight, return rank dot straight, and on down. Right? We just keep on working through these. And now it's complaining because I don't have the methods. That's okay. I haven't written them yet. Flush, straight, three of a kind, two pair, pair. Right? So if is three of a kind, return rank dot three of a kind. Right? And we're just doing all these with helper methods. Okay? And if is two pair, return rank dot two pair. If is pair, return rank dot pair. Pair, nope, pair. And otherwise we return high card, right? If we're not any of the other ones, we must be a high card. Okay, and now it says, well, I don't have these methods. So sure, let's go add the methods. Yes. Create the method for me. Sure. Is three of a kind. Create the method for me. Sure. Is two pair. Sure. Create the method for me. Is pair. Create the method. Okay. Awesome. So I got a bunch of methods here. Again, we probably don't want to always return false every time, but that's okay. We'll get there. I'm going to move these back down, again, just to keep these organized. Usually your public stuff's at the top and your private stuff's at the bottom. It doesn't matter much, but that's okay. Okay, so we have to figure out how we do these then. You guys with me so far? So, and straight flush, actually, it's going to be nice to have that as a method name, but we're just going to return is straight and is flush. Right? If we're a straight and we're a flush, then we are a straight flush, right? Don't do your same logic twice, okay? These other ones, right, we have to figure out. So, okay, let's finish flush. Flush looks pretty easy so far. So if the suit of the 0th card matches the suit of the 1th card, right, and on and on and on. If 1 matches 2, and 2 matches 3, and 4 matches 5. 1, 2, 3, 1, 2, 3, 4. So if all the suits are the same, then we're a flush, right? You don't need to say, if this is true, return true. We can just return this, because this is either true or false when we AND it all together. Okay? How about a straight? You know, I should have written some tests first. Feeling bad now. We should write some tests first. And then we should make the tests pass. How's that feel? All right, I'm just going to return false for now. Let's write some tests. So do we have any I didn't add any tests yet. Okay, so poker hand tests. And we were talking in Discord, hopefully you saw that, about testing, right? The idea that we need to test our tie breaks, because that's the code, right? So we have a bunch of code for testing all this stuff out. So some classes here will, or I'm sorry, some ranks will tie, and some ranks can only win or lose. Remember when we talked about our poker hand ranks? Poker hand, there we go. Snap that down here, right? A straight flush can tie, because you could be a straight flush of a different suit. A four of a kind cannot tie, right? Because you have all four of that number. No one else can have four of the same number if you have four of that number, right? So don't worry about that. It either wins or loses, okay? A full house will always have a winner or a loser because no two people can have the same three cards. Flush could tie. You could have the same cards, but the tie break, right, you go to the highest card and then the next highest card and the next highest card. So all five cards have to match for flush to match. A straight, you only have to look at one of them to see if they match, but it could tie. A three of a kind will have a winner. Two pairs can tie, one pairs can tie, and high cards can tie. So most of them can tie, but not four of a kinds, full houses, and three of a kinds. Okay? So, call is where most of this is going to happen. So this is a four of a kind here is going to have a winner and a loser. Right? So we're going to do our arrange, we're going to act, and we're going to assert. Okay? So I'm going to need some cards. Right? So I'm going to make a card, or I will have an array list of cards, array list of type card for player cards, player one cards. Here's a new array list of type card. And let's add some cards. Okay, sure, import, yep. Add, and let's see, if we want a four of a kind, let's add a bunch of new cards given card.face. I don't know, what do you want to do? How about sevens? Let's do 4 sevens. And card.face. I'm sorry, card.suit. And suit. Card.suit. There we go. How about we do, that doesn't matter, right? Because we got to do all four of them. So spades. We'll add another one. Hearts. Clubs. And diamonds. Okay, so we have those cards, and then we'll just add one more random card. It doesn't matter. How about, like, say, a 10? Sure, 10 of spades. It doesn't matter. That's a four of a kind. Okay, and we're going to do it again for a different player's hand. Player 2 cards. And let's do maybe, how about fives? And the other card doesn't matter here. Okay, so we got all this set up, and then we need hands. So I'm going to make a poker hand. Hand 1 is a new poker hand, given the player 1 cards. And a poker hand of hand 2 is a new poker hand, given the player 2 cards. Okay, and then I'm going to have an expected result here. So I'm going to have an expected, or a poker hand dot result, right, is an expected result. Well, equals poker hand dot result dot win. Win. Okay. Then we actually act, right? Now let's do the thing. So we'll take a poker hand result of an actual result. So this actual result equals hand 1 dot call hand 2. Okay, and then we'll assert that they equal. So assert assert equal. There we go. Oh my goodness, yeah, there we go. Expected result and actual result. Okay, and if you wanted to here, now we could also flip this around. Result. We'll call this win. And then I'm going to have a second one. Instead of a second test, I'm just going to flip this around. Let's do where we expect to lose. Lose is if we flip it around and do it the other direction. If hand 2 calls hand 1, that one should lose. Okay. Add another one in here. Because I want to make sure it works both directions, right? I want to make sure I'm not always saying a hand wins. I want to make sure I'll also get a loss result. Actual result, loss. There we go. Okay, so that's for the four of a kind. And we're just going to do this over and over and over for all the different hand ranks, right? So 4 of a kind, straight flush, full house, on and on and on. So the straight flush draw is probably a different test, right? And I'm just going to copy paste because I don't want to have to type all of that again. Call straight flush here. Okay, so they all need to be a flush here. So I need all the same suit. So I'm going to do all spades here. And we'll do 7, 8, 9, 10, and say jack, right? Why not? Okay. And then my opponent, then, if I'm going to win and lose, let's say instead of a jack, now we give him a 6. And probably of a different suit, right? Hearts. We'll just change the suit. A double click here should highlight an entire word. And then I'm just Control V for copy paste. Copy paste it in. So the first hand should beat the second hand, and the second hand should lose to the first hand. Okay, and then we'll also do a tie. So we'll just do a tie here. So if we're the same but different suits, then I'll put this back to a jack here. I don't need to do it a second time. Tie. Or draw, right? I think I called it draw. Actual result. And draw. And draw. I don't know. Maybe it's annoying to have those named like that, but that's okay. Okay, so now we've tested out our straight flushes. We tested out the 4 of a kinds, and on and on and on and on. Do you want me to keep doing more tests, or can we go back to just writing poker hand? What do you guys think? I'm up for either. I can do either one for you. When we tested, they should all fail, right? Because I haven't actually built all that logic yet. Actually, I think it's going to crash because I have some of those. Yep. Oof. Cannot invoke array list because cards is null. What did I do wrong? Where? Add objects. Oh, I forgot. Yep. Okay. Got to add player card 2 here. See, this is what happens when you copy paste stuff and you're not paying attention. So I have to fix all of those. It tried to sort the second hand, and it couldn't sort the second hand. Because I never added cards to the second hand. Weirdly, a test passed. What is... Oh, get hand rank was empty. Yeah, forget that. Oh, and I did mention we probably could also throw that in as a test here, right? So we could, while we're testing these, throw in another test here. We might have a pokerhand.rank, actual rank, equals pokerhand.rank.4 of a kind. Right, and we'd have an expected rank up here in our arrange. Expected rank equals pokerhand.rank.4 of a kind. I'm sorry, not actual rank here. So it's our hand1.getRank. There we go. And then we can assert those are equal as well. Assert equals the expected rank and the actual rank. Okay, cool. So we can do all those. And let's run our tests again now. Now it shouldn't crash on me, or maybe it still will because I didn't finish poker hand. Yep, okay. This cards is null still? Add 1. This cards is null. Interesting. Huh. Okay, I did some wrong poker hand. Oh, yeah, right here. I was telling you about this in deck. I've declared it here. Doesn't mean it's done, right? Cards equals new array list of type card, right? We have to initialize it here. I could tell it it's 5. It doesn't matter much. There we go. Now those ought to, fail successfully. Let's come back in here. These, I don't want these unsupported. So I would just want to return false for now. False. Okay, so let's copy all those. Okay, and that one. Okay. All right, so those should all work now. Let's try our tests again. Hopefully we don't crash. Seriously? List is null. Where? List is null in poker hand, line 18. This.cards. Oh, this.cards is a new array list. I was setting the card variable. This is what happens if you use the same variable names like I do. It's all right. We're learning. We're learning. Let's run the tests. Ah, yeah, click on the line number. That's right. Thank you. All right, expected win, but we got lose. Okay, that's fine. We're losing for who knows why. Something's not working right. That's okay. Oh yeah, our tie break, right? We just lose, but we don't have a tie break. Okay. All right, so hand ranks. Let's keep on going here. So something that I find useful for doing this, right, as we're looking through, well, how do I find out if I'm a 4 of a kind? Some people went the route, you say, okay, well, once I'm sorted, either the 0, 1, 2, and 3 indexes are the same, or the 1, 2, 3, 4 indexes are the same face. Sure, that works. It's harder for full house, right? And you can do it. You can either do the 0, 1, and 2 are the same, and then 3 and 4 are the same, or you can do 1 and 2 are 0 and 1 are the same, and 2, 3, 4 are the same. And that starts to get really tedious to me. And trying to get all of that in there is a little bit obnoxious. And then 2 pairs even harder. So I came up with a different way. So I said I want to add a private, and I know I said I almost never use arrays, but this one's easy enough as an array, int array. I'll call this a face count. So what I'm going to do is I'm going to set face count equals a new int array, and I'm going to put in zeros. So I'm going to count up the faces, the number of times each face shows up. And I've got 13 faces, so I'm going to put 13 zeros in here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Ought to do it here. 13 faces. So until I've counted all the faces, I have 0. Then what I'm going to do is I'm going to say, every time I take a card now, I'm going to take my face count, index of my card.ordinal, or card.face.ordinal, and I'm going to add 1 to it. So take the value here and add 1 to it. When I find 0, ordinal 0, sure, added 1. Ordinal, next ordinal, add 1, add 1, add 1, add 1, add 1, on and on and on. So it's going to count the number of times each face shows up here. Does that part make sense? So we're just going to go through and use that ordinal value, 0 through 12, to count how many times that ordinal came up. Okay, so then in 4 of a kind here, I can say for int face count, or I don't know what face in face count. Shoot, that should be probably plural. Face counts then. Face counts. Okay, face counts here. So for face count in face counts, if face count is equal to 4, return true. No, return true. True. I'm sorry, that's Python syntax. Oy. What am I doing here? If we've looped through all the face counts and I haven't returned a true yet, I haven't found a 4 of a kind, return false. Okay? I do this exact same thing here for 3 of a kind. If I find a 3, great, I found it. Hydration, thank you so much. Okay? 2 pair. Now this one's a little bit trickier. Let's do 1 pair first. Pair is, if I find a 2, I have a pair. 2 pair is I have to do this twice. So I'm going to have another int pair count. Starts off at 0. And if I find a pair, I'm going to take pair count plus plus. When I'm done, I return pair count equals 2. Oh my goodness. Pair count equals 2. Okay, if I found 2 pairs, I return true. If it's not 2 pairs, I return false. Okay, so full house then is 3 of a kind and is pair. Right, I don't have to do the same logic twice. Right, if I have a 3 of a kind and I have a pair, I'm a full house. Done. Okay, so this face count thing is really helpful for checking these sorts of values. Right? All right, then the last one here. I need to check all of my ordinals here. So now I'm getting face dot ordinal if it equals the next one, get face dot ordinal minus 1. Because this one you have to know which order you're sorting in. So if we're going from low to high, this one should equal the next one minus 1. Right? Each card should be the next face, should be the ordinal should increase by 1. We just do the same thing over and over and over here. And I'm just going to force some order of operations here. It's not needed, but it's, you know, makes this more specifically clear what we're doing here. So each one all the way on down then, from 1, index 0, index 2, 1, 2, and 3 should match index 1, 2, 3, and 4 on down for straights. Excuse me. Okay, so that's all my little helper methods here to get the hand rank out. Okay, now we have to do the tie breaks. Okay, so different hands will tie break differently, right? We said 4 of a kind and full house and 3 of a kind all will have a definite winner or loser. Okay, so let's do them. Let's do 4 of a kind. Sure. Let's go back here. We'll say if get hand rank is equal to rank.4 of a kind, we need to tie break it this way. Right? Well, I need to find which was the 4 of a kind. And I already have the face counts. So I'm going to go do this face count thing and find which one had 4 of a kind. Okay, so I'm going to get this is an int for my 4 of a kind. A kind is going to, so I'm going to loop through. So I'm going to start off at 0 for now. I'm going to say for index 0, index is less than my card, or no, my face counts dot length index plus plus. And if my face counts, so I need the index here because that's going to be which one is bigger for me. I can't do the enhanced for loop because the value it stores is 4, but I need to know which index it's at here to know which one is a higher index. So face counts of index is equal to 4. My 4 of a kind is equal to index. Okay, that's it. We could break out of the loop or we could just let it run forever. It doesn't matter. I think breaks are gross, so I'll skip it. But you could break. It's fine. Okay, so I do that for mine, and I'm going to do the same thing for theirs. No, I should feel bad if I have the same code twice, right? Right? We should feel bad about that. So let's do this. Let's extract this as a method. Refactor. Introduce a method. Let's call this get index of face count. Sure. And this needs a int, I don't know what, count. So if you tell it what count you want, we're going to loop through and we're going to return it. When we're done, we return, this is index of count. We return the index of count. So I want 4, right? So this is my int, my 4 of a kind index. More coffee, you're saying, Phantom? Mark? Yep. I actually drank all my coffee already, unfortunately. Oops, that should be an int type. Okay. I'm starting up at 0. It's probably not actually 0, but that's okay for now. And we'll have an int for their 4 of a kind. Index is the other hand, right? Other hand. Dot get index of face count 4. Okay, and then I'm going to return here, or not. I guess I need to check. So no, we're tie breaking and we can't lose. So we'll say if my 4 of a kind is greater than their 4 of a kind, return result.win. Result.win. Result win. Okay, if we didn't, we lose. Result.lose. Turn result.lose. Okay? That makes sense for how we tie break our 4 of a kind hand? So this gets a little bit big here, but it's okay. We got all of our tie breaks in here. Okay. So we're going to go on down. So we did the 4 of a kind. We can do them in order. Our straight flush. Right now, some of these will tie break the same way. Right, a straight flush tie breaks the same way as a straight. Okay. Because they're both straights. So we can do both of those at once now. So let's did the 4 of a kind. Let's do if get hand rank is equal to rank dot straight flush or straight, or get hand rank is equal to rank dot straight flush, straight flush. Okay, we can tie break. Let me give that a format. Okay. Now with a straight, right, the cards are going to be in order, and whoever has a higher card wins. Right? It doesn't matter which one I look at because they're going to be in order. So, and we're going low to high. So I'm going to look at the first card, and if it's higher, they win. If it's lower, they lose. And if it's the same, they tie. So we're going to check if, excuse me. I guess we could do the, like, an ordinal, I don't know, we'll just check. So we'll say if cards.get 0, let's get the first card, dot face dot ordinal is less than the other hand dot cards dot get face dot ordinal. Oh my goodness. Return. So if we're less than theirs and we're both sorted, then I lose. Result.lose. Okay. And again, there's no real else here because if we returned, we're done. Right, it's kind of silly to have that being an else. So, I could take that off here too. Sure. Else is redundant at that point. If we're greater than, oops, we're going to return result.win. If we didn't lose and we didn't win, we tied. Right? Draw. We drew. Okay, for straights and straight flushes, we just need to look at one card because we know they're in sorted order. So whoever has the lower card loses, or if we have the same, we draw. So that's those ones there. Right, so we've done straight flush, we've done 4 of a kind, we've done straight. Now, flush is going to tie break the same way as high card. Right? Full house will tie break the same way as 3 of a kind. So let's do the full house and the 3 of a kind next. Right? Whoever has the higher 3 of a kind is going to win. Oops. So if get hand rank is equal to rank dot 3 of a kind, or get hand rank is equal to rank dot full house, we do the same thing we did up here with 3 of a kind index, 3 of a kind. And we want to get the face count of 3. Okay, we either win or we lose. You guys with me so far? So it's 3 of a kind and full house. Just compare a 3 of a kind. So it's nice we have this helper method here already, right? The get index of face count for a given count. Boom, right? We're done. Okay, and pair works the same way. Pair. 2 pair does not, unfortunately. So 2 pair is a little bit harder, which is obnoxious, but that's okay. We'll get to that. Now pairs can tie though. So actually we're not done yet. So else if, or I guess there's no return there. We're going to check if it's less than, then we lose. Otherwise we might draw. Okay, so it's possible we might draw here. Might draw here. So we have to figure that out. So if my pair is better than their pair, we win. Great. If my pair is worse than their pair, we lose. Great. If we have the same pair, well, we need to check all of the other cards. Okay? And what happens when we check all of the other cards, right, we're going to go in order, high down to low. Okay? So we need to check cards from high to low. So this is actually something we're going to do a lot here. So I'm going to write another private helper method here for a rank result. check high to low cards, given a poker hand, other hand. Okay, and we're going to say for index is 4, because we want to start at the end. Index is greater than or equal to 0. Index minus minus. Go on down. I'm going to say if my cards dot get the index dot get face dot ordinal is we can say greater than, right? Why not? Greater than the other cards dot this, other hand dot cards dot that. Okay, if our card is greater, that's a win. Turn result dot win. Nope, not draw. Win. Else if, right? Or just another if here, right? There's not an else. If we're less than, we lose. Return result dot lose. Okay? If we've checked all of them and we haven't won and we haven't lost, we must have drawn. Result dot draw. Right? Because if we check all cards in order from top to bottom, high card, next 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 high card, and we didn't win or lose, we must have drawn. They're going to be the same. So the draw here then, we just return check given the other hand. Oh my goodness, why is that not there? Okay, so that's how we tie break the pair if we didn't win or lose with the pair already. Okay, and we do the same thing with a flush. Right, we do the same thing with the high card, so let's check for flush. So we do need to be a little bit careful in here to do this in the right order, because we want to do higher ranks first. So we might run into some trouble here. I think it's going to work, because pair is going to trigger if we are also a 2 pair. Because as soon as we find a pair, we need to win. So we need to do the 2 pair up here. That hand rank equals rank dot 2 pair. To do. We'll do that one. We'll get back to it here. But then our flush, right, and our regular high card. So straight flushes, we'll do flushes up here. So if get hand rank is equal to rank dot flush, not final flush. I don't know why it keeps giving me the wrong suggestions there. We're going to do our method. Return check high to low card, given the other hand. Right? Check every card in order. As soon as we find a higher card, we win. And then this is also our default, right? This is default high card. So if we didn't match any of the other ranks, right? If we weren't any of the other ones, then we must be a high card hand. And that's going to make this method happy because it needs to return something. And if you have that inside of an if, it's going to be upset with you and say you didn't return anything. Okay? So that's our default. We assume it's a high card. So we need 2 pair. Well, to tie break 2 pair, we need to find the face of the higher pair and then the face of the lower pair. Right? And that's where it gets a little bit messy. Okay? Because we have to find which is the high pair, which is the low pair. Okay? So we know how to get 1 pair, right? Right? And we know our helper method here is going to go from low to high, because it's going to start at 0 and then work its way up. Okay? So we need to find, so what it's going to give us is the lower pair. If we really want the higher pair, we could do that sort of thing. We can do it both ways. I like the helper method, but I know it's going to give us the lower, so maybe we just do it again. All right, we'll just do this. We'll do this. We're going to copy paste, feel a little bit bad here, but it's okay. Index of high pair. Okay, we don't need to return anything. It equals a 2, and now we're going to start at paste count length. We're going to start at the top here and go to as long as we are greater than or equal to 0. Going down. Right? Is that going to format? Okay. So we're going to go on down to find my index of high pair. You know what? If I'm going to do it twice, though, I might as well make a method because I have to do it for the other hand as well. You know, so forget it. Let's just make a method. Let's do another helper one here. And that's fine. We can have private helper methods. So private, this is an int get index of high pair. Yep. We're going to loop through index of high pair. Did I copy the wrong thing? I copied the wrong thing, didn't I? Index of high pair. This needs to, you know, starting there, greater than 0. Okay, this is good. This is good. When we're done, we're going to return index of high pair. Wait, no, I had enough semicolons there, or curly braces there. Because I need to do this for both hands, so I might as well have a method out of it. Right, start at the top index, work its way down. Now, it's only going to work for pairs, but I'm only using it when I know the hand rank is a pair. We're okay. So I'm going to say an int my index of high pair, get index of high pair, and an int their index high pair is the other hand dot get index of high pair. Okay, and then I'll have an int my index of lower pair is my get index of face count 2, and theirs, right, is the get index of face count 2. This is lower pair, right? Low pair. Okay. So my high pair, their low pair, right? Because I know mine, this one will count high to low, this one will count low to high. As I wrote it, we know which one it is. So we're first going to check our high pair. Actually, we don't even need to check the lower pairs first. We can check the high pair. So if my index of high pair is greater than their index of high pair, we win. Result.win. Oh my goodness. Result win. If it's reverse, if it's lower then we lose. Result lose. If we didn't win and we didn't lose, now let's check the lower pair. Okay. Okay, if my index of low pair is better, I win. If my index of the low pair is lower, I lose. If all of that didn't happen, oh my goodness, well, then where did it go? Where did our method go? I'm losing it here. Check the high to low card. Other hand. Because if all of our pairs are the same, well, we got to check all 5 now, right? Or whatever that 5th one is. I don't want to find what the 5th one is. Let's just check them all in order. Because if I'm down to the last card, great, the pairs will be in the same place in both hands. Whoever has the higher card is going to win. Is that right? Because if we both have pairs of kings, right, and someone has an ace, their ace is going to be the higher card, they're going to win. Right? I think that works. All right, so let's run our tests. We had a couple unit tests, see if they pass now. And our tests passed. We had a couple pass. Right? I didn't write all the unit tests. You guys, if we want, we can write more unit tests. I trust you guys can probably figure that part out. I don't need any of this nonsense. There. Okay, so I think poker hand is done. Right? We have wins, we have loses, we have tie breaks. So let's make sure we have tie breaks for all of them. We have tie breaks for straight flush. Yes, straight flush and straights. We have tie breaks for 4 of a kind. Yes, straight flush, 4 of a kind. Tie breaks for full house and 3 of a kind. Yes. Flush, yes. Straight, yes. 2 pair, 1 pair, and default high card. Okay, I think this one's done. You guys okay with this? That's 240 lines of code, right? Not too shabby. Not too shabby. Okay, the last thing we have to do is the game part. Okay, now we should go write the game. Okay, so I'm going to have an int for player money. I don't know, I forget. I thought I said a number, but I didn't put it in D2L, so whatever you gave them is fine. Computer money is 100. And while they have money, we want to keep on going. While player money is greater than 0 and computer money is greater than 0, let's keep on going here. Let's loop. So I'm going to need a random equals a new random. What else am I going to need? Let's see. That's probably enough for now. Right, so we're going to make a new deck. So deck equals a new deck. So top of each hand we make a new deck. Gives me 52 cards, and I get a bunch of random cards. That's okay, Phantom. It should be fine. Because that's how they bet, right? Is that they have money to bet with. We should track that. Maybe that wasn't super clear. Okay, so we're going to make a new deck, and then I'll make a poker hand. Oh, actually, we need the list of cards. We're going to have an array list of type card, player cards equals a new array list of type card, and we'll just size it to 5. Sure, why not? And we'll do it for computer cards. And yes, we want to import array list. Thank you, NetBeans. And player cards dot add deck.get random card. And I want to do this 5 times, right? So for int card number 0, card number less than 5, card number plus plus. No, plus plus. Come on, NetBeans. Work with me here. 5 times. Let's give a card to the player, give a card to the computer. Okay, now we each have 5 cards. Now we'll make poker hands. Poker hand, player hand is a new poker hand, given the player cards. Right, computer hand is a new poker hand, given the computer cards. Okay, now we got hands. So they were like betting $1 each time automatically, and then the player had an option to raise or not. So in main here, we're creating the instance and declaring it all in one line here. So we're declaring the type here. If we wanted to, we could declare it out of the loop. It's essentially going to do the same thing. This might be a little bit less memory efficient. So yeah, so maybe we should put them up here. Sure. And then this just instantiates them. We can declare them, and then we can make instances of them. And we do the same with deck. Deck. And deck equals new deck. I like that. That's clean. Right? Put all your variables at the top. That's good habit. Okay, and we'll do the same with hands, right? Poker hand, computer hand. I like it. So if you have all your variables up at the top, it makes you look like you know what you're doing. Like you've thought through what variables you're going to need for your program. Okay, each time we just make new instances, though. So we're going to throw out the old one in memory, put a new one in memory. Oh, what we don't have is a card to string. That's right, we're going to need a to-string for card. Override, public string, to-string. So I can print out these cards, right? So we're going to turn, that's a base dot to-string, I think, plus of plus suit dot to-string. I think the two strings work. Capital S string. Okay, I think the to-stringing it will give me the right result. We'll find out here. So then poker hand should probably also have a to-string. That's right, we'll add that in. We'll add an override for public string to-string. So we need a string, so we might as well be clean about this, right? We make a string builder equals a new string builder, right? That's the proper way. We've talked about this, right? And for card in cards, string builder dot append card dot to-string. Okay, and then we return string builder to-string. Okay, remember, string builder is the proper way, so we can add a bunch. We don't have to make new strings in memory all the time. Okay. So then, just for fun, for now, we're just gonna let's print the player hand. Player hand. That's player hand. And we'll print the computer hand. And plus the computer hand. See what we get. Okay. It's going to loop forever, so that we'll just put a breakpoint in. Just want to see if it's going to print something out. It's the first time running it. I'm crossing my fingers here. Whoa, it didn't stop. Oh, I hit run instead of debug. Oh my goodness. Yeah. Okay, so the poker hand not quite done, right? And things are running together here. So then we should also append between them string builder dot append maybe a space. Right, so we separate those. Okay, And then let's come back to our project. Let's run it in debug mode, make it stop actually, and see if we get a hand. So definitely not as pretty of an output as some of you. Someone had put in chat using the Unicode values for like the characters for heart and diamond things. So 2 of hearts. Maybe we should put some commas in too. What do you guys think? Poker hand, a comma and a space. Let's try that. Okay. All right, so 6 of spades, 10 of hearts, jack of spades, ace of diamonds. Oh, there's a trailing comma and a space. I feel bad about that. Let's fix it. So we wanted to do .substring. Remember we talked about substring? We want to start at substring. We want to start at 0. We want to go to the string builder dot length -2, right? Take off the last 2 characters. And I think substring already returns a string, so we don't need to do that. So this will trim off those last 2, right? Trim the last 2 comma space characters. Okay? Let's give it that a run. See what we get. Right, we want pretty output. So 4 diamonds, 6 of spades, 8 of spades, 9 of clubs, king of clubs. Stop. Looks good. Let's step one more. Have it print the computer hand. 3 of clubs, 6 of clubs, 8 of clubs, jack of clubs, queen of diamonds. Awesome. Cool. Maybe we also want the hand rank. Right, we could do that. So sure, let's should we do the rank first? That might make this a little cleaner here. Right? So let's take our string builder and we'll append the get hand rank .toString. And then append in a space, or maybe not a space, but maybe a dash. Why not? Okay, let's give that a stop, give it a run. And this was, you didn't need to do any of this necessarily, but this is just trying to make it nice and clean here. See what we get. So a pair, 3 of hearts, 3 of spades, 5 of hearts, 6 of clubs, 9 of spades. Okay, looks good so far. Get the computer hand with a pair, 8 of clubs, 8 of spades, 9 of diamonds, 10 of spades, queen of spades. Awesome. Okay, so we've got that. So we want to print the player's hand. We want to give that to them. And we want to ask them what they want to do. So let's take that breakpoint out. Posture check. Thank you. Thank you. I'm slouching here. How can you tell? Put my board in here. And we're going to do a scanner. Maybe we might as well do the scanner up here, right? Scanner. Keyboard equals a new scanner. Given system.in. Awesome. So we'll ask the player. Do you want to raise or call? And we'll have a string for choice. Keyboard.nextLine. Hydration. Oh, thank you so much. I wish I had more coffee. I am not hyper enough as is right now. Okay, and if their choice was equals ignore case, right? Because who knows what they're putting in here? Equals ignore case. Let's do the raise one first, right? If they say raise, otherwise we'll assume it was a call, right? Sure, why not? So we need to take some money out, right? So we need an int for the pot here. We're going to have, I don't know, an int for pot. It's going to start off at 2, and we're going to take the player money, minus minus. We'll take the computer money, minus minus. Okay, so if they raise, then we'll take the pot plus plus. We'll take the player money minus minus, player money. If they raised $1, then we need to ask the computer, right, whether or not the computer is going to do something. So we'll do if random.nextInt, and we want 2, so we want 0 or 1, right? That's a 50-50 chance. So we'll say if it's a 0, sure, the computer folds. Computer folds. And maybe we print out the computer hand, right, just for fun. You know, actually, we're going to print out their hand both times anyway. So they fold, so we'll take the player money plus equals the pot. Okay, they get the pot. If the computer didn't fold, then they call, right? So we'll say computer calls. The computer money goes down by 1, and the pot goes up by 1. Okay, and then we need to print out the result. So we're going to print out the player hand dot call the computer hand. Oh, we need what that result is. So now we get a poker hand dot result is what we get back from call. And if result dot, oops, result, poker hand dot result dot win, so you win. You know what? All of this is sort of silly because we're going to do this exact same thing in the call over here, right? Right. So why not? So let's skip all of that. Okay. So really, that doesn't even need to be an else, right? The call action then is still going to happen. So if we raise, then sure, and the computer might fold and we win the money immediately. Sure, and here maybe then we cheat and we say continue. Where that continue here, this goes back to the top of the loop. Right? We're done. Right? Otherwise, we add some money to the pot, computer calls, we'll go do something here. We'll print the computer hand. Computer hand. Okay? And then we need that result. So if we win, we take the player money plus equals the pot. If else if the result equals poker hand dot result dot lose, we lose, and the computer money gets the pot. Else we must have tied. Oops. Else that's got to be a tie, right? Or a draw. We draw, and we each get half the pot. Plus equals the pot divided by 2, and the player money plus equals Monday. Oh my goodness, where did I get Monday from? Plus equals pot divided by 2. Okay. And oh, I got too many curly braces there. So we probably also want to print out how much money we have, right? Oh, yeah, we want a scanner. Did I import the scanner? Nope, import scanner. Okay, and we restart again. So maybe we print out how much money they have too, right? Player has plus player money. And the computer has computer money. Okay, and then we'll see what our hand is. We run a raise or call. They might fold and we just stop. They get the money, we're done. Otherwise, the computer calls and they get some more money here. And then we print out the computer's hand. We see who wins. Let's try it. Okay, we have a pair. Let's raise. The computer folds, we win. We have a high card. Let's raise. We're just going to... Ooh, the computer calls. They called our raise. So we lost here. Computer hand had a 2 pair. 2 of clubs, 2 of diamonds, 8 of hearts, 9 of hearts, 9 of diamonds. And we had just a regular pair. 2 of diamonds, queen of clubs, king of spades, ace of spades. Oh, we had a pair of aces. That's a pretty good hand. Let's see what that was. I guess shrink that down just a little bit here. Right. Oh, this is our new hand. So now we have a pair of aces. Okay. So now we should definitely raise with a pair of aces, and we win. Okay. Now we have a high card. Let's just call. All right. We lose. The computer had a 2 pair. Raise, raise, raise. We're just going to bully the computer because they're going to fold half the time anyway. Raise. See if we can get anything good in here. Look at that. We're winning. We're taking their money. Really, anything other than... Oh, no. That's just calling, isn't it? Raise. I got to type in raise every time. We got any good hand yet? High card, pair. High card, pair. High card. I'll just call all the time. Pair, 2 pair, 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 high card. Come on, give me a good card. Give me a good hand. Really not have a better hand? All these hands can't do better than a high card? Flush! Oh, there we go. We got a flush. Okay. 5 of hearts, 7 of hearts, 10 of hearts, jack of hearts, ace of hearts. Not a bad flush. We just need to keep raising here. Yeah, we're going to take all that computer's money. Because they just fold half the time. Ooh, a 3 of a kind. There we go. We got a 3 of a kind. All right, I think we got it. Feeling okay. Again, probably use some more looks here, but it's been quite a little while here. So I think it's time for a break. Think of your questions if you have them. Let me post this to GitHub for you so you guys can take a peek while we take a break. So this project 2 solution. And we can go from there. Yeah, I got to get some dinner. I had a yogurt earlier. All right. Look at all those tendies. Oh, dad joke. All right, all right. Oh, I just had a good one here. Let me find it. All right, dad joke, and then we take a break. We put some music back on. So you think that the word Q is kind of a funny word, but Q, right? A lot of people think that you just pronounce the first letter and all of the other letters are silent, right? Q, U, E, U, E, that sort of thing. But it turns out all the rest of the letters are just waiting in line. Yeah, that was a good one. Alright, gang, welcome back. Oh man, guys are making me hungry with all the talk about Chipotle. All right. So, questions, thoughts, concerns before we move on from the project? I know this one was rough for a lot of people, so don't be discouraged. There was a lot to it, but hopefully breaking it down piece by piece by piece, solving one small problem at a time, made it a little bit more tackleable, manageable. And again, there's partial points for everything, right? If you got one rank good and you weren't able to figure out the other rank, like if you couldn't figure out 2 pairs, don't worry about it. It's just 1 point out of the 15 there. And then the next project, the one we're going to talk about tonight as well, is going to be worth more points. So the first project was 10, project 2 was 15, the next one's 20, the one after that's 25. Right? So they increase in points to make up for anything you might have missed in the first set. Okay? Cool. All right, I'm going to pause real quick, and okay, let's do this real quick. Maybe throw out a poll. We'll do project 2. C, D, E. Just throw out a letter. It's all anonymous here. Go ahead and vote for what you think, how you did. This will just help everyone else get a sense for how other people went. I had a lot of people say that they think they're just not getting it, and they must be the only one. And I feel like that's not true based on all the conversation we've had and all the chat. So it should be in Twitch chat there, so you don't have to associate it with your name. It's just a poll result. Like up at the top of chat, you can vote. Let's see what you guys think. All right, help each other out. Vote for how you think you did. And it's okay. There'll be a chance for some points in the other projects as well. All right. Oh, we're only down to 12 people watching. Okay, so maybe most people are breaking for lunch or dinner, but all right. It's only a couple votes. That's okay. Yeah. All right. What it is. Yep. All right. Okay, so I got that out in GitHub. I pushed that one out for you. We can close that one down. And we'll start a new project. I can't spell either. Don't worry about it. Don't worry. Ian, what are you doing? Ian, what? You want to say hi? Here, say hi to everybody. Here, there, you're on camera, Ian. Here, say hi. Good boy. Good boy. Okay. All right, I gotta type though. Chapter 10. 10. Evening. Yeah, he's real talkative. He's always been one of my loudest ones. In the middle of the night when he's bored and just meowing in the hallway because we lock him out of the bedrooms at night, it's real loud. But that's okay. That's okay. All right, I'm going to try and see if I can accomplish this here. Oh, how did I do? I forgot to about the in real life word bands, but I think I wasn't using the words. I think I did pretty well here. Let's see. All right, I think we're good. Let's check in. I got a couple of emails I had to respond to. Oh, did any of you folks make it to the SI sessions? I didn't. All right, awesome. I will keep trying to do that. I'll do my best. Usually, I should put like a time limit on it, right? So, for the next 20 minutes or something, but it's all right. I have to figure it out. Not yet. All right, I'm doing well. We're going to have trouble with that when we talk about inheritance. That's unfortunate, but that's okay. So I'm going to do a really boring example. I apologize. And hopefully you've seen this already. One of the things we're supposed to talk about in 1500 is inheritance. We might not have done a lot with it, but that's okay. So at least be familiar with the topic. So we're going to talk about polygon. Right? Polygon has an int number of sides, and it has a private array list of type integer, capital I integer, right? We have to do the boxing thing for side lengths. So when you make a polygon, you need to tell it the number of sides. And, we want to import array list. Thank you. All right, I have to pet the cat while I'm doing this. That's just tricky. Oh, yes, import array list. I clicked import. There. You tell the number of sides, and we'll make the array list, side lengths here, right, equal a new array list. Array list of type integer, and it should be sized to the number of side lengths. Number of sides, sorry, number of sides. You know, actually, we never use that number anyway. Let's get rid of it, because the length of my array list is the number of sides that I have. Okay, and then we'll add a method for set side length, given an index and a length. Okay, so the problem is, though, we need to go add now. So until I know otherwise, right, I don't have any values in here, so I'm going to set them all to 0. So I'm going to loop through. So for an index is 0, index is less than number of sides, index plus plus, and we're going to go add in a 0. So this defaults them all to 0. Lengths, man, side lengths. Length is a hard word. A hard word to spell. Yeah, lengths, right? I think I got it there. Probably did. Okay, we'll set them all to 0. Right, the constructor's job is to set values for all of its attributes. So if you give me an index, right, I'm going to take my side lengths, and I want to set, right, the index and the length. Look at that. Even suggested it for me. Oh, length over here. Length. Man. It's all right. You don't need to be a good speller to be a good programmer. Don't worry about it. Okay. Then another thing we can do if we have side lengths is we can calculate perimeter. Yeah, perimeter. Perimeter. That's probably right. We're going to have an int for perimeter. Starts off at 0, and then for int length in side lengths, perimeter plus the length. Nothing super fancy so far, right? And we can return the perimeter. Okay, so we make a polygon. You tell me the side lengths. I'll tell you what the perimeter is. Okay, that's basic. Now, assume we want to do something now that is special. We want to be a polygon, but we want to have a specialized behavior. That's what inheritance is all about. We are a type of our parent class, or superclass, or base class, right? And we're going to have a derived class, or a subclass, or a child class out of it. So I'm going to add a new class here. New class. So let's call this rectangle. And rectangle, then, where you say extends polygon. So extends is the keyword here to create the is a relationship. Okay? And right off the bat, it's yelling at me. It's really upset with me because polygon has a constructor. The constructor polygon cannot be applied to the given types. Required int found no arguments. So what happens by default with inheritance, the parent class or superclass constructor gets called automatically. All right, Ian, oh my goodness, you are in the way, cat. All right, so because there is no argument constructor, it's upset with me. It says I don't know how to call the polygon constructor because you have to give it an int. So what we do is we call super. So super is the, oh, sorry, this has to happen in our own constructor, rectangle. Okay, there we go. So in our constructor for rectangle, we're going to call the superclass constructor. This calls the polygon constructor. So the rule for this is it has to be the first thing you do. So call to superclass constructor be the first thing you do in a subclass constructor. Okay, so we have to call that. That way it sets it up. So now rectangle is a polygon. Okay, but now what we need to do is we need to change the behavior of polygon. Because I know I only have 4 sides, but I don't want to let people set side lengths independently because a rectangle has the same lengths and the same widths. I need to force that. So what I'm going to do is I'm going to override the behavior. I'm going to add an override. I'm going to say, hey, I want to change the behavior of this set side lengths. Give it an index and an int length. So when you go to set the side length, I'm going to change it here. Colon. That's usually like the scope operator specifically is colon. For inheritance in C++, what do you even do? Okay, come on. I thought there was a different word for it here. What's inheritance? And it's not off the top of my head, so let's Google it. See what we get here. I think it's just a single colon when you're doing it. Let's try this one. Yeah, it's just a single colon here. So that is the extend keyword. They use a colon in C++. Yep. All right, cool. Look at that. We can find the information on the Googles. Okay, so we want to change the behavior of set side length. So we're going to override this particular thing that I'm not allowed to say. Hey, Blowfish, thanks for coming on by. We're having fun learning about inheritance tonight. So if you set the side length, so if the index is equal to 0 or index is equal to 2, I'm going to set them both for you. But what I need to do, because I'm changing behavior of set side length, I still need to use my parent class's behavior. Right? I don't have access to side lengths because it's marked as private. And the only place you have access to private variables is inside of your class. So no one else can use set side length. So the only way I can get at it is calling set side length. But I just said I'm changing the behavior. So what I need to do is I need to say, hey, superclass dot set side, I'm sorry, super dot set side length. And I'm going to give it 0 in the length. And then I'm also going to give it 2 in the length. So I'm going to set both 0 and 2 to the lengths if you go to change either one of them. Right? Otherwise, I'm going to set 1 and 3. Okay? I'll set 1 and 3 to the length if it's not a 0 or 2. Okay? So this way I'm making sure that the lengths stay the same and the widths stay the same. I'm changing the behavior of this. So when you use rectangle, you get this behavior, but I'm still taking advantage of my superclass's version. So that's the override, right? We've overridden toString before. Remember, object has a toString method where you get like the class name and the memory address, and it's garbage. It's not very useful for us. We have to override toString all the time. Okay? Give that a format. And then another thing we can do, we're going to add more behavior. So we've overridden behavior. We changed the behavior. Now we're going to add new behavior. So we're going to have an int for get area. And it's going to return, oh, well, I need a way to get out my side lengths, right? I don't have a get side lengths. So I need public int get side length, given an int index. And we're going to return side lengths dot get the index, right? Whatever value is there, we'll get it back out, okay? So for an area, then I'm going to return get side lengths. Remember, because I am a polygon, I have all the methods of polygon. I get all these public methods. Times get side length of 1. Right? Length times width. We can calculate the area. You okay with that so far? So then let's just try it. Let's just make a rectangle and a polygon for fun. Polygon, I don't know, shape equals a new polygon. Say let's 5 sides, who knows, right? And then we'll shape dot set side length. 0 and 1. 1, 2, 3, 4. I don't know. Let's just keep increasing it. Who knows? I don't know what kind of shape this is. We'll just do some nonsense. Your shape's perimeter is shape.getPerimeter. Okay, and let's make a rectangle. Rectangle, rectangle equals a new rectangle. And rectangle always has 4 sides. We don't have to give it number of sides. Right? It's fine. And then we'll set the side lengths. Set side length of 0. I don't know, we'll set to 5 and maybe 1. We'll set to 10. Sure, we could do that. You know, that's also a little funny, right? Wouldn't it be nice if we had like better methods? Oops, not get side lengths, side lengths. There we go. Wouldn't it be better if we had like a set width and a set length? Right, we can also do that. Public void set width. Width. And a public void set length. Give it an int length. Sure, why not? Okay, you give me a width, you give me a length, we're good to go. So let's not repeat some code here, right? Let's just set length. And then we'll set width. Okay, sure, we made it a little bit cleaner here. So we got better methods that, you know, make a little bit more sense. Now we don't get rid of set side length. So they can set it individually if they want. But now we've got an easier way to like set length and set width. No, why does it keep doing that? Set width. There we go. 5 and rectangle dot set length, say 10. And then we'll get the perimeter of our shape. Rectangle dot perimeter. Okay, and we can also get the area out because rectangle knows how to calculate the area. Get area. Notice they're all here, right? Because we have that inheritance relationship, we get the perimeter. And if I click on it, it's showing me, hey, it comes from polygon. Get side length comes from polygon. Get area comes from rectangle. So it's nice and it tells you where you're getting those methods from. Okay, so let's give it a run. Okay, so it shapes, perimeter is 15. Oh, we should have said rectangle, right? Your rectangles. Is that apostrophe? It probably is, right? Rectangles apostrophe because it belongs to it. Sure. So 15, right? 1 plus 2 plus 3 plus 4 plus 5 is 15. That makes sense. And 5 plus 5 plus 10 plus 10 is 30. That makes sense. And 5 times 10 is 50. I think our numbers make sense. And I didn't write unit tests for it. We're just kind of eyeballing it here in main, our poor man's unit tests. But that's okay. I'm not going to feel too bad about it. Okay, so we got those. Now what if we want to customize rectangle even further? What if we want to add another specialized behavior? Let's add another class. You can have as many levels of inheritance as you want, right? As many as make sense. So let's add square. We'll say square extends rectangle. Okay, so we need a constructor. Now notice square is not yelling at me right away because its parent class rectangle has a no argument constructor. So it doesn't yell at me and say, oh, you have to call the constructor right away, which is fine. But I'm going to have an int for length in my constructor. So when you make a square, you give it a length. Okay, so the first thing I'm going to do is I'm going to call super. Now this happens implicitly. Whether or not I say this, it will be called implicitly. Implicitly, than if we don't explicitly call it. You know, I like doing it just as a reminder, hey, it's going to happen. It doesn't hurt anything to be here. It's just superfluous. Superfluous? Is that the word? There's some sort of word. You banned all the wrong words. You should ban the silly words. Okay? And then I'm going to call the set length. No, not that one. Set length. Given the length, and I'm going to call set width. Set width to the length. Boom, done. Square is done. Right, but oh, maybe we also want to override though our side length, right? Set public void set side length. Now this is where it gets a little bit silly because set side length, int index and int length, because I don't want someone to be able to change them outside of my control. Right? My job as a class is to maintain the integrity of my class, so I need to protect it and ensure that you can't give it invalid lengths and widths. So whatever you give me, I'm just going to call set length and set width, right, to that length. Set them both. Sure. Okay. Now, and if you call override void set width, int width, I'm also going to do both. And if you call set length, I'm going to do both. Oh, that should be width, right? So I need to override all the behavior that I want to ensure doesn't get me into a bad state. Length. Length. Okay, so I'm overriding all of those versions to make sure that the right thing happens. Uh-oh. Now it's telling me, hey, it might recurse. Uh-oh. As I'm overriding it, I'm calling it. So what's going to happen is it's going to call itself, and it's going to call itself, and it's going to call itself, it's going to call itself, it's going to call itself. So we need to make sure we're saying super dot. Use the superclass version, not my version, right? That's a nice warning. That was smart, right? Because we want to do the superclass version, not my version. Because my version would call the other one, which 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 would call the other one, and you just be ping-ponging back and forth, back and forth, back and forth, back and forth, over and over and over and over. Okay? How are you guys feeling so far? We'll pause for a minute here. See how you're feeling. Well, I'm adding width and length because if someone calls set width and I don't have it defined, it's going to do this, which would make me no longer a square. So I'm saying, hey, I'm a special version of rectangle, but you can't change my width independent of changing my length. So I'm going to change the behavior of it to make sure the right thing happens. Okay. Wait just a minute here. I gotta see how far we got with Tuesday. Let's see. Yep. Yep, set side lengths, good. Rectangles, good. All right, awesome. And then the rest we did this morning. All right, awesome. So the next thing, real quick, I want to show you, and then we'll talk about the next project. And then I think we'll be good to give you some time. I think we're in pretty good shape. This is good. Is this crazy thing. So we've talked about inheritance. Right? It's an is-a relationship. It's not a has-a. Remember, like deck has cards. That's a has-a relationship. Deck is not a card, and card is not a deck. Right? So the inheritance relationship there is not appropriate because it's not an is-a. Nope, polygon is just a class. Nope, because it has attributes and it has methods and it has things defined. Yep. So super says get my super class. So super is the super class to you. So it's whatever you extend. So super dot something is the polygon dot set side length method. So it's your super class. So this we'll call the constructor of your superclass, and this we'll call the superclass version of methods. Okay? Awesome. So that's inheritance. Creates the is-a relationship, not a has-a. I think there's a way to build diagrams. I haven't done that in a while. I should. I think there's... So super says, hey, call my superclass constructor, hand it 4. Because polygon has a constructor that needs a number of sides. So we're saying polygon constructor, I have 4 sides, I'm a rectangle. I thought there was a way. Is it under tools, maybe? I don't know. Let's Google it. NetBeans generate UML. See what we get here. Oh, here's a hit. Start NetBeans, click new project, Java category, Java class, features, UML. Visual Paradigm for NetBeans. We don't use Visual Paradigm. I think actually we have licenses at the school, maybe. It's been a while. And, ooh, JDeveloper. It's a free modeler. There we go. Neat, you can get some cool stuff. So it looks like you need a plugin for NetBeans. Best I can tell at my first glance. That's a good question, though. I like UML. We don't do enough of it, I'm sorry. We should spend more time doing some UML. Okay, so inheritance, right, is a. Has a means you have a bunch of, but you're not is a. So the inheritance relationship, right, is a. The reason why we write classes, again, right, we want to encapsulate all of our details. All of the things about that class, typically nouns, right, belong as private attributes. And what we expose is our public methods. So that's our abstract way of interacting with the class. Right? We don't know how scanner works. We just know scanner.nextLine gives me whatever the user typed in. Right? We're interacting with it through its public methods. That's its abstract interface or its API. Right? You have code and you get to call methods on it, and we don't care how the methods work. We just know that they do things. We're doing the same thing. No one needs to know how we figure out perimeter. Right? This is kind of nonsensical, but that's okay. All they know is they get a public method that does it. So our classes encapsulate their details, and they expose through an abstract interface their methods that they do. So that's the idea of abstraction. There's a little bit more to it, but that's the gist. Okay, so we encapsulate We have abstract interfaces that we interact with, the public methods, and then we have polymorphism. Such a fun word. Polymorphism means I can treat one type as another type. Right? I get polymorphic behavior. So what I can do this nonsense here. I can say I want an array list of type polygon shapes equals a new array list of type polygon. Okay, and yes, I want to import array list. Thank you, NetBeans. And now I can take shapes and I can add my shape. Right? It does make sense, right? Shape is a polygon. I can add shape to my polygon list. What I can also do now is I can add rectangle. No, rectangle, that one. Because rectangle is a polygon. Right? It is a, so it fits. So polymorphism means if it fits, it sits. Like a cat, right? If I fits, I sits. No, if it is that type, we can treat it as that type. Okay. Then I can do shape.add. I can add a new square. Say of, I don't know, 7. A square is a rectangle, which is a polygon, so I can throw it into my list of polygons. Okay, then what I could do is I can call methods on them. So like shapes.get0.getPerimeter. That one's not all that interesting. What about like set side length? Let's see if we can. I swear I didn't type set side length. I don't know, 0 and I don't know 5. Why not? We'll change some. And let's change the length of the rectangle, and let's change the length of the square. And then we're going to say for polygon shape in shapes, let's print the shape.getPerimeter. Why not? Perimeter of shape. Okay. Did I spell it wrong? Shape. Oh, it's already defined. Sorry. Polygon. Sure. For each polygon in shapes, let's get the perimeter printed out. Now, shapes of 2 here, right? Shapes.get2 is a square, but I don't see the getArea method. I don't see the setLength and setWidth method. The only methods I see are the ones that belong to polygon, because I'm treating it as a polygon. Right, so because this is an array list of type polygon, I only get polygon methods. Okay, but there's going to be magic here. Let's take a look at this magic. So let's put a breakpoint in. Okay, and I'm going to run it in debug mode, and we're going to take a look and see what happens when I call set side length. Okay, so right now we've got our shape here, side lengths. We set 0 to 5. Right, it was a 1, we changed it to 5 right here. That happened. Okay, here, actually, let's step back one. I can't move that up one, sorry. Let me restart. Let's watch that one happen too. Okay, so I'm going to step into my code here. Let's step in, and I see polygon set side length. Right, I'm in the polygon class. I'm setting side length. Index was 0, length is 5. Sure, it's all well and good. That happens. Now I'm here at line 33. Let's step into that one. Set side length, yep. I'm in the overridden version. I'm in the rectangle version. So while the code is running, we get this cool polymorphic behavior in which not only can we treat the subclass as the parent class or superclass type, but when we call an overridden method, Java says, oh, you really are this, you want this version, and gives you the right version. This is phenomenal. This is amazing behavior. And this is one of the tenets of object-oriented programming, is that we can treat things polymorphically. And I can get the correct behavior based on the actual type, even though we might treat it as its parent type. So now we're going to set the side lengths appropriately. Not that one, I don't want that. Set the side lengths, I want to step over, that's what happened. Okay. Set the side lengths. Oh, did I might have messed it up, didn't I? Let's see, rectangle. Yeah, set width and set length. Oh no, that's fine. Yeah, because we called set length and set length. Okay, we're good. I'm sorry. Getting myself all mixed up. So now let's do it here for square. Let's see. Do we step in? Do we get square? Square set side length gives me square set side length. So at runtime, it's saying, oh, you actually are a square, even though we think you're a polygon. Let's do the right thing because you are a square. So it's matching up at runtime. Okay? And then we set side length, goes to the rectangle set width. Rectangle set width goes to set side length of polygon. So we follow this whole chain of calls here, and it all happens. Okay, and then we're going to output, so let's just continue to the end here, and we should get perimeters 19, shape, the next shape is 20, and then a square with the sides of 5 should be 20. So let's see, rectangle was 5 and 10, and we set length to 5 essentially, so we got 20. Looks like it works. So that's the polymorphic behavior. All right, that's about as far as we're going to get tonight. The next week, we're going to finish out Chapter 10, talking about abstract classes and interfaces, which are phenomenal. We're going to need abstract classes for the project, but don't worry about it. It's not super critical to have right now. We'll talk about it next week and fill in that little gap that we have there. But it should be okay to start it off. So what I need to do is I need to pull up Desire to Learn, and I need to go find the project. So I didn't actually post it for you guys yet. My apologies. I'll get that posted. I posted for the morning class. I'm going to go copy paste it into your class. This is the fun of having multiple classes. And I'm sorry, I haven't got your project 1s graded. I meant to get it done and got busy and procrastinated, and you know how that is. So I'll be working on that tonight, tomorrow, and over the weekend to get those in for you. Sorry for the delay. I know you're waiting on those scores, so I'm sorry. I'll get it to you shortly. Let's see. No rush on 2. So we are going to build a text-based kart racing game. It's as fun as it sounds, I promise. Now, the problem with this one here, let me actually open up Desire to Learn again here, is if we look at our schedule, we've got some interesting stuff coming up. Okay, so let's take a look at our schedule. See what's on tap. Oh, and I gotta get the quizzes graded. Oh man, I just shouldn't assign as many things, right? That would solve all my problems. Okay. So tonight, week 1 of inheritance. Week 2 of inheritance, next week, winter break. We don't meet. I don't want to give you anything over winter break. The next week, midterm review and exam. Again, I'm going to leave the exam open. It's a 2-hour time limit for the exam. We'll spend the first 2 hours of class doing review if you guys have questions. You can take it anytime during that day. You guys are welcome to drop in on the morning class or watch the recording of the morning class review if you want to take it earlier in the evening and not wait till 6 p.m. to do the last minute review and then take it that same night. I'll do what I can to make that work for you. And then the week after that is 318. So I don't want the project to be due the midterm when you're working on that. So the project's going to be due on 318, which is a lot of time. But as you might have noticed from project 2, that time gets burned real quickly. Okay, so do 318 a month from now, 4 weeks from now, right? There's still a month. I guess that's equivalent in this case. But you're going to want to start early. Okay, that's the little warning there. Definitely start early. Okay. So we got up our new assignment here. This is, come on, D2L. Project 3, text-based kart racing. Due 318, 6 p.m. Okay. Oh, I can't. And you're going to just give me a link to your code in D2L. I gotta save it and reopen it. I don't know why. Yeah, the midterm exam, open book, open notes, open internet, just not open friends, right? I get paid a lot of money to write code, and no one has ever asked me to do it from memory, because that's stupid, right? Obviously, that's stupid. Okay. So we're gonna add a new project here. for project 3, this one is worth 20 points. So the first project was 10, project 2 was 15, this one's 20 points. Okay, so you can make up on some of those points that you might have missed out on earlier. Or at least it'll be weighted more heavily in this overall scheme of things. Oh, I still need that open, don't I? All right. So our text-based kart racing. So all the stuff from chapter 10. We're going to only build the classes for the game. We're not doing any user interface. So no one's actually going to play this game. But the idea is we're going to write all of the classes that we need so that maybe someone can make it into a mobile game. Maybe someone can make it into a web application. Maybe someone can make it into a desktop application. Who knows, right? We're just going to write the classes, and then however they want to use those classes, they're going to be able to use them. So remember, the idea is when we build a class, we take all the details, encapsulate them in, we hide all that stuff away, and we give them public methods. So that's the key here. We're going to have classes with public methods that could be used to build a game if we were so inclined to write the user interface. Okay? So our kart is an abstract-based class. Again, don't worry about the word abstract right now. We'll come back to that. So kart is an abstract-based class. Karts have max speed, they have acceleration, they have current speed, they have brake speed, and they can hold an item. We're going to have subclasses for light karts, heavy karts, and motorcycles, because we've introduced motorcycles in the latest Mario Kart. Kart racing game. Okay? So karts will have methods for accelerate, which increases their current speed by up to their acceleration, brake, which reduces their speed by up to their brake speed, and get methods for all their attributes, and a method for use the item. And if they're holding an item, they should be able to use the item. Okay? Light karts, in general, we don't enforce this, but this is kind of the idea with light karts, is that they accelerate faster, they brake faster, but they don't go quite as fast. Their engine's not as big. What we're going to do, and a light kart enters a bend, it gets a chance to brake before taking the penalty. We'll talk about the bends in a minute here. That's the special version of kart that light kart is going to do. Okay? So heavy kart. Typically, they have lower acceleration and brake speed, but a slightly higher max speed, right? Because it has a larger engine. But again, we're not enforcing this. This is just an FYI. It's the kind of things we'd expect. The special thing heavy karts do is they can actually have 2 items. So when you add an item or use an item, right, we should get special behavior to handle having that second item here. And then motorcycles usually have best acceleration and brake speed and max speed. They're small and fast. The problem is they're more fragile. So if we get hit by a shell, slip on a banana peel, or go off the road, we lose an extra turn from the wipeout. Okay, none of that makes sense yet. Sorry. Now let's talk more about what happens. So we're going to have a class for track. Track is going to have a list of karts along the track, and it's going to track their position. So it's going to know where it is on the track. That's kind of the idea. Okay. So again, most of the tracks are like circles or have some sort of funny shape. We don't really care about that part of it. All we need to know is distance from the start. Okay, we'll have a start and an end, and they'll have some distance in between. So it's going to have the total distance, and then a series of bends, or turns. So each bend should have a max speed assigned. And if a kart goes into the bend, or crosses that distance at which it starts, above the max speed, they'll go off-road and stop. So as the track is bending, if you hit that above the max speed, we're saying, oh, you weren't allowed to turn, you didn't turn fast enough, you hit the wall, and you stop, and have to reset yourself. Okay? So track needs a method to return the distance until the next bend for a given kart and the max speed of the upcoming bend. So we need to have some information that we can give to the karts about, hey, how far away is the next bend? So the idea is that as we're playing the game here, they can say, oh, a bend is upcoming. Do you want to accelerate? Do you want to decelerate? Do you want to use your item? Or whatever happens to be every turn. Right? So we're going to have items that can be collected on the track at given distances. Karts can only have a single item at a time. Don't do the remove and respawn on the track. Just everyone gets the item as soon as they cross that distance. We won't deal with that complexity of oh, you picked it up, it's gone for 5 seconds or whatever. So when you pick up an item, it can randomly be one of the following. It could be a mushroom item, because everyone knows mushrooms make you faster. They increase your max speed, so something above your max for 1 turn, and then your speed goes back to max. If you get a shell, you can shoot it. It can be shot at any kart that's ahead of you. It causes the target to stop. Or a banana peel gets dropped at your current location on the track, and the next car to pass that location will spin out and stop. Right, so as we use an item, we're interacting with how far we are in the track. The track needs to know, oh, there's an item now here. Or, hey, we shot something, we need to find the next car, the next closest distance ahead of us. Right? Or we're going to increase the speed when we use our item in our turn here. We're not writing the game that manages turns. Right? We're skipping that part. If you want to, great. Maybe we can talk about some makeup points there if you want to actually implement the game portion to make up for stuff you missed in 1 and 2. I'll entertain that idea. But the idea is for each turn, the cart gets to take their action and then travel its current speed along the track, picking up items or entering bends as appropriate. Right? And that's the game. So we're just writing the classes here. Okay? So again, we'll come back to abstract base class. We'll get to that later. But this is cart, and then we have special versions of carts, light carts, heavy carts, and motorcycles that do certain things. Okay? Thoughts, questions, concerns? I'm going to add a rubric later for you guys. I haven't gotten that done yet. Sorry. I'll get that in soon. But we do have a little bit of time. Don't wait to the end, though. Right? As you can see, that doesn't go well. Okay? So we're just going to have a little fun with it, try and build out a silly shell of a game. Okay? But you don't have to write the game part. Right? So don't stress about that. We're writing the classes and public methods to let them interact. Okay? Thoughts, questions, concerns? A hat. I'll change my hat, sir. Going to take off my chest bra hat. Some OG chess streamers. We'll go back to Mickey Mouse. I do love my Mickey Mouse. I can't wait to go back to Disney. Super excited. Another hat? You're going to change again? All right. Sorry, 22 or 27. Mark, gotcha. I have to wear the other one, I guess. That's fine. All right. So we are actually up to date on all of the things the morning class did. You have the music to it. No, you can't add copyright music, right? Definitely not copyrighted music. We're not allowed to do that. This hat is awesome for when we're outside, in the sun, when we actually had sunny days and stuff. All right, so that's all I've got. I think we're up to date from all the things we did in the morning classes. Again, so take some time, recoup, just feel better, and get started on this project if you want, or just take some time. If you submitted to D2L, I got the project. Right? If it's in D2L and you can see it on github.com, I'll be able to see it. Okay? If you got questions, send me a message, shoot me an email. We can go from there. If not, we'll pick up the extra. Conducting the Super Mario music for jazz band? Oh, that sounds awesome. That sounds awesome. I miss band and orchestra. That was good times. All right. So you guys take care. I'll see you next week. We'll finish up Inheritance, the rest of the chapter. We'll talk about the rest of the things you need for the project. I'll post a sample midterm for you guys so you can practice over break if you want to have the review early, and I'll go over the answers. All right. You guys take care. I'll see you around.